My name is Carly Maxwell. I am the Chief Engineering Technician in the Department of Mechanical and Manufacturing. There are many labs in the Department of Mechanical and Manufacturing, and in these videos, some of the labs will be highlighted.
CNC milling machine. It's a small milling machine, but it is for the purpose of simulation and prototype. Yeah, so here we have a CNC lathe. It's a small one. We do it mostly for simulation and projects. We look into the machine, right, and make sure it sets properly before we can do our cuts. When we run our programming, you can come to the program, the computer program, and you have our delete here, delete or our stop. From our program, we'll be able to see if we have programmed the cut correctly, such as here I will do a simulation. So you can see where the tool is taking the cuts and all the codes is running here. Here we'll be able to tell if our cut is too deep or too shallow, where we can also adjust it onto the program. So we can see when we do our tool change and if it's going correctly. Right, there you can see we have our product. So from our programming, we will know if we made any mistakes, and it will show instantly. So far our programming is properly and good, so we can go ahead and do our cuts.
You can be my farmer. Yeah. Mau harus bikin sokan sampai sekarang si periode.
Good morning. My name is Ronald McDonald and we're here in the metallographic lab where we focus on image analysis and sample preparation. And this is a service we provide to the second year and final year students. We even go all the way up to postgraduate route. For the second year students, we focus on an introduction to metallography, where the students will come in and we give them samples based on known specimen, something that we're familiar with, we are accustomed working with, we know the expected outcome, so that they are going through the steps of procedures, learning to use the equipment and getting an appreciation for what is done in the metallographic lab. We first start them off with sectioning, where we cut a small section of the sample, we take it to the press where it is mounted, and then we go into grinding, polishing, and etching. After the sample is etched, we will now bring it to the microscope and have them do what we call image analysis. As they are doing the image analysis, we will explain to them the different elements that they're seeing. We work with different type of metals, both ferrous and non-ferrous. We have even done things like bone, tooth, skin, hair follicles, paper, wood, bamboo, and so on. We have the ability to do almost any solid in this particular lab. For the final year students, they are focused on their final year projects. So they will come in being already familiar with the lab because they have a final year lab also. And when they come in, we now start them into sample preparation for their final year projects. Be it a machine part or something that they're designing and building, they want to look at the different types of material that are available to them and different material that they can use to make a better choice for their project. This here is a little snapshot of the metallographic structure and the grain size schematic for the imaging. For the cold rolling lab, what we do, we give the students a brief introduction and we walk them through the different stages of the cold working and how it affects the material specimen or sample. This is more for the final year students, where we put a specimen in the rotating fatigue machine and we carry it to failure. And we will analyze at what point it failed and how the structure encourages the failure or influences the failure.
My name is Amar Anjarbandhan and I'm a technician at the university attached to the Mechanical and Manufacturing Department. One of my responsibilities is conducting lab sessions in the metrology lab with the course code MENG 2008. The purpose of the lab is to sensitize students with some of the common measuring instruments, like the vernier caliper, vernier height gauge, the depth dial, and the profile projector to some extent. At the end of this lab, students will be able to properly handle, store, and take proper readings and measurements using the different devices or instruments. For the depth dial, we have an apparatus to get the reading of the rise and fall in the cam. For this, we have a magnetic base used to hold the dial, and we have V-blocks used to properly hold the shafts to get proper rotation. And here you'll see where they measure the difference in the rise and fall of the cam. For the inside and outside micrometers, students are exposed to the proper handling and use of the micrometer, as well as the calibration process. Students are given the ability to use both inside and outside micrometer and take measurements of an engine block as well as pistons and component parts, connecting rod and gudgeon pin. In addition to, they are given the exposure whereby they understand the importance of calibration, zeroing of instruments, and the proper handling and use of micrometers, both inside and outside micrometers. Again here, the outside micrometer accuracy is 0.01 of a millimeter, and the inside of bore mic accuracy is 0.005 of a millimeter. For the vernier caliper and the vernier height gauge, students are allowed to take different readings and understand the difference and how to properly use the vernier caliper both inside and outside, and the depth application. The accuracy of the vernier caliper is 0.02 of a millimeter. For the profile projector, we use the PV350. Students are allowed to analyze a bolt to find the major, minor, and pitch diameter, as well as the thread angle. Students are also exposed to using the TPI gauge to find the number of teeth per inch on the bolt.
Good day, students. Welcome to the Tear Down Laboratory. In this exercise, students will put to use what they learned in the metrology lab. Students are asked to take apart engine and automobile components to get their desired component. Students are asked to measure and draw the component. Tools, measuring devices, vices, tables are provided to execute this task safely and efficiently. After this, we proceed to do a hardness test followed by a spark test. The spark test is done to tell what type of material it is. Students work as a team to complete the given exercise.
Hi, good evening. My name is Barry Mirage, and I'm attached to the Strengths Material Lab. The objective of this experiment is to determine the stress and strain characteristics of a number of common engineering materials. The main piece of equipment in this experiment, Tensor Olson, is a universal machine and it has a capacity of 25,000 liters. The sample is placed between two chucks, or we could say it's locked in between two chucks. The machine is set at 10 millimeters per minute, so students will be able to see the failure of the sample. The elongation gauge is used to measure the sample after it has been cleaned. These readings are in percent. Reduction in percentage. Instrument use, reduction gauge, it's measured in percent. And what we do, we take one of the samples and we try to get a reading at the minimum point or the narrowest point of the material.
One of the tests that we do in this lab is with Rockwell hardness. It's an international standard measurement for hardness of different materials. Rockwell hardness has its own hardness scales that we use to set up the equipment. So for instance, let's say we wanted to find out the hardness of this aluminum sample. We can come down to the scale and look to see where it falls in terms of the application. So under applications, I've seen aluminum alloys, which will use a 100 kg load, which you would see there's a preset load of 100 kg. The indent to use is a 1/16 of an inch diameter steel ball. That's the indenter that sits here at the moment. It's scale 2 and the reading will be B. So all the readings we would put B in front of it so you would understand that this was Rockwell B79, so that no matter where these results go, you will understand what they mean, what scales or parameters were set. So ensuring that the material surface is clean, set it at this point on the equipment, turn the arm in a clockwise manner, with a small dial reaches the set position, gently push the back, wait an average of about 10 seconds, then gently pull forward, which will give us hardness of this material. What you need to note is that each time you do a hardness test on the material that you have, there's a little indentation mark from the indenter. So you need to shift away from that so as to ensure you do not repeat the test in the same area where the properties within this region would have been changed. So you shift your sample to a new position and repeat the sequence. You repeat this sequence on average of 3 times, where you'll be able to get an average reading to determine the Rockwell hardness. So your reading would be B8 in this instance, and it's going to be on the red scale. Thank you.
What we have there is indication of where the sample was tested. So what we have here is the impact testing machine, Brooks, and we use the ISOT scale. 3 samples used in this experiment: aluminum, brass, and steel. Each of them have 3 notches that we're going to obtain 3 readings on the Brooks impact testing. The sample is set. This is 0. Mark here, and again, on the scale of 0. You also test the sample with respect. Sample has been impacted and focused. On the ISO scale, students take that reading. For each division, 1 division is equal to.
So this here is the hydraulic trainer. It's part of the hydraulic lab, which is part of the traction lab. Here students are afforded the opportunity to run different hydraulic circuits and test different components. You have different hydraulic cylinders, your pump, pressure gauges, valves, so they test, troubleshoot, and able to get a good hands-on experience of what hydraulic circuits and systems are.